take a 10-minute break here will be Tao Yang, who currently is interning at Hunt Electric, and his partner, Ashley Chapman. They will be presenting on power and mechanical equipment.
I'm Ashley Chapman, this is Tao Yang. For our industrial project, we will be presenting first and second floor power, panel schedules, mechanical and owner equipment, and the Duct Layout. Receptacle placement was spec'd in and told us where most of the receptacles needed to be placed. But we also place extras where we deem necessary or for convenience or as required by the NEC. So this is our electrical and mechanical rooms on the first floor. Highlighted in yellow are all of the receptacles that we place. In the reception and office space, we place floor boxes underneath all the cubicles to be hardwired to. Then we also place receptacles along the perimeter of the room and try to circuit about 6 to 8 receptacles per 20 amp circuit. First off, in the bathroom, the NEC states that you need a receptacle in any bathroom and that it shall have GFCI protection. In the computer room, receptacles along the walls give us a separate circuit to plug appliances into so that we don't interfere with any computer harmonics or anything like that. Moving up to the second floor, in the mechanical room, the receptacles are placed for convenient access while maintaining the air handling units. So you can plug in any drills or any type of equipment that you need power for. In the break room, there are quite a few dedicated circuits. It's basically treated like a kitchen. So circuit 23 feeds just the refrigerator, circuit 24 feeds just the dishwasher, and then circuit 25 feeds the GFCI protected countertop receptacles. And then each vending machine also has its own dedicated circuit. And then circuit 22 is just basically your convenience receptacles. In the research lab, we fed each side of the lab bench with its own circuit. It comes to a junction box in the ceiling and then runs down a power pole, and then it's then attached to the multi-layout assembly on each side of the benches. This picture shows an overview of the entire roof power. There are 5 exhaust fans and then 1 cooling tower. In more detail, 210.63 states that a receptacle for servicing shall be located within 25 feet of any heating, air conditioning, or refrigerator equipment. So we place those receptacles likewise, weatherproof and GFCI protected. Panel schedules. In the 100 amp receptacle panel, like I said earlier, we loaded each 20 amp circuit with 6 to 8 receptacles, generally with some exceptions for special equipment that usually could need more power or might not be used as heavily loaded. For the lighting panel, we used all LED fixtures, so the load is fairly minimal for this side of the building, giving us a 200 amp panel. And then on each 20 amp circuit, there's roughly 30 to 40 lighting fixtures. And they're all grouped according to their general location. We also installed a 100 amp emergency panel, which is the first load that the generator picks up in the event of a power failure. Fed from this emergency panel, we have all emergency lights on 2 20 amp circuits and another 20 amp circuit feeding all of the exit lights. If you look at these plans, each of the lighting fixtures that is half shaded represents an emergency light, and they're just placed basically to give the quickest path out with enough light. This is on the first floor, and then the second floor as well. In the main distribution switchgear, it feeds all the major equipment as well as the sub-panels. Some of the loads include chiller, both environmental chambers, both mechanical panels, the lighting panel, transformers, bus duct, and UPS. all of these loads are served with 48277 voltage. We chose to go with Cutler, Hammer, Eaton electrical equipment. This is just a picture from the cut sheet used for our distribution. And then this is just another general picture of the switchgear from Eaton for the spec sheets of the product that we use for the switchgear. So now it's Tom.
Good morning, everyone. Again, my name is Tom Yang. The overview of what I'm going to go through is mechanical equipment, plus duct layout, and a bit of coordination through Navisworks. So here's our mechanical equipment that we based on during our layout for and circuiting for our mechanical equipment. We didn't have no control circuit for our mechanical equipment, so we use disconnects and VFDs to control our speed and torque of the mechanical equipment. Here's the first floor mechanical layout. As you can see, you have a mechanical room over here with the boiler and your chiller, which is the biggest motor running in your whole building. And for the beer room, we have the PDUs, which are fed from UPS, and your computer units, which cools your computers and your PDUs. This is the mechanical panel for your first floor. We got 300 amps for the total panel, and they're all three-phase, including all the amps and circuit breakers. Here's the second floor layout. We have the environmental chamber connected to your main switchgear, and your air handling units are connected to each VFDs, which controls and manages the speed of the air handling units. On the rooftop, you have your exhaust fans. You have 5, 4 on the main roof and 1 on the small roof over there on top of the mechanical room. And you have your cooling tower on top. Mechanical panel 2, this is a 400 amp panel. We calculated based on how many equipments we installed in this panel. Bus duct layout, this is the overview of our busway or bus duct layout. A little breakdown on each room. Here's our 480 volts and a 280 volts. 480 is fed from the main switchgear, 4,000 amp. And 280 volt is fed from the transformer 2. The manufacturing floor, we installed disconnects according to the machine that are installed to it. There's your owner equipment, and we have each machine marked on the disconnect. For example, you have machine 1, there's 12 of them. You have machine 1 and 12 machines that are marked with number 1 machine. And we use SO cables, which are based on 405.2. And our own equipment, you're supposed to look at it. You have your overcurrent protection size and your SO cables and your amp size. For SO cables, we multiplied our amps by 1.25, went to table 402.5 to get our calculations for cable size and our overcurrent protection size. Bit of Navisworks, like Phil was saying earlier, bit of coordination and grid modeling. We're pretty fortunate that we didn't have to worry about any clash detection for the mechanical work. Like for example, air ducts and whatever piping. Here's our overview of the manufacturing part. You have machines and your plus ducts up there. Our dark one represents the 480 volts, and the white one represents 280 volts. For lighting, our lighting is suspended 15 feet above the floor, and cable trays are mounted 17 feet, and our 280 volt is mounted 18 feet, and 480 at 19 feet. Here's our little overview of your bus duct going vertically into the walls to go into your main switchgear and the transformers. you have a better look at it. You can see the space between the bus ducts. And from these bus ducts vertically into and horizontally into the next room, to the space between the mechanical room and you have the lights are not interfering with them. Next room, this is the 280 volt going to a transformer and the 480 going to the main switchgear. Here's an overview look of the electrical room. You have the main switchgear that from the 480 or feeding the 480, transformer 2 feeding the 280 volts, and that's your transformer feeding the receptacle panel, which converts it into utility 120. And your ATS emergency panel and your generator and on-site panel. That's it for conclusion. Any questions?